Hello, this is Mike Kramer. I'm the calibration / inspection program at Perry Johnson Laboratory Accreditation, and I want to welcome everyone to this month's monthly webinar, which, believe it or not, will be the last one for 2018. Today's topic is, actually, we're going over two sections within 17025, the 2017 standard. We're going to take a look at the requirements specified in 6.3, which is a section on facilities and environmental conditions. And we're going to also roll right into section 6.4, which is the section on equipment. As always, this webinar is being recorded. You can go directly to the website at pjlabs.com. We have a tab for recorded webinars. Hence, when we're finished here today, shortly thereafter, this should be uploaded. Also, for your listening and viewing pleasure, will be a wealth of webinars we've done over the last several years. So they're all titled, so if you want to go back and review this one, or anyone that we've done over the last several years, they're there as a resource for you all. If during this webinar, which is set for 1 hour, if you have any questions, you should have a question box located on your screen. Type in your questions. We do not no longer have to wait until the end of the session. If a question comes to mind during the course of this presentation, please type it in. When I conclude with the today's presentation, I'll take a look at them, we'll review them, and I'll try to answer them to the best of my ability. So, getting into today's presentation, section 6.3, we're going to take a look at that at first, which is facilities and environmental conditions. So, in looking at comparison to the 2005-2017, the requirements are pretty much still intact. There's no significant changes. One thing that is magnified here are in those situations where tests for calibrations are performed in facilities outside its permanent control. The new standard requires that environmentals and facilities related to any requirements be met. So we're going to look at that requirement. We're going to drill down a little bit deeper as far as exactly what that is specifying. And we're going to go through all the requirements. Some of them are very much the same, if not worded exactly the same as within the 2005 standard. So, very first requirement, the facilities and environmental conditions shall be suitable for the laboratory activities and shall not adversely affect the validity of results. Note for some added information that is specified in the standard, some adverse influences can include, but not limited to, things such as microbiological contaminations, dust, electromagnetic disturbances, radiation, humidity, electrical supply, sound, temperature, and vibration. So a little cartoon picture there is depicting some things that may not, as far as observations, may warrant not fulfilling the requirements as stated in 6.3.1. Incompatible activities, perhaps you have sensitive equipment that's nearby a area which is actually producing vibration. Maybe an example of conditions which would adversely affect the test for calibrations that are being undertaken. The requirements for facilities and environmental conditions necessary for the performance of the laboratory activities shall be documented. Typically, this is within your own procedures. I have an example there. So if you have a procedure, be it a test or a calibration, and the test and or calibration procedure is specifying, for example, temperature is to be within 68 degrees Fahrenheit, plus or minus 2 degrees Fahrenheit. Relative humidity is less than 50% relative humidity. The UUT, or unit under test, must remain in the laboratory for a minimum of 12 hours prior to calibration to permit thermal stabilization. Calibrations are not to be performed if the environment conditions are outside the allowable limits stated above. That's just an example. I'm sure there's various tests or calibrations. The environmental condition requires for it may be very tight and may be very broad, but there are specific environmental conditions which must be met that needs to be documented. Hence, what I put here is an example of what we're referring to here. Along with that, the laboratory shall monitor, control, and record environmental condition in accordance with the relevant specifications, method, or procedures, or where they influence the validity of the results. So if you have those conditions specified, they're documented. They need to be monitored, such as depicted here by perhaps a data logger, or if they need to be captured real time. Temperature, humidity type device, if those environmental conditions are important to the activity that's being undertaken. Nothing new here. That's always been required within in the 2005 standard. 634, measures to control facilities shall be implemented, monitored, and I bolded here, periodically reviewed in bold type there, because that is an addition, and shall include but not limited to access to and use of areas affecting laboratory activities, prevention of contamination, interference, or adverse influences on laboratory activities, effective separation between areas with incompatible laboratory activities. Those requirements were in place prior. It's just been expanded and that they need to be periodically reviewed. Example I've tried to depict down there is perhaps in order to comply with this, a sign was posted outside the door. Periodically going back, looking at this, what was in place to comply with this standard. There may be additional personnel may have been observed going into the area that perhaps disturbed the area in testing. Hence, perhaps would warrant perhaps a card reader to depict a change that need to be made based on periodic review of the of this particular requirement. When the laboratory performs laboratory activities at sites or facilities outside its permanent control, it shall ensure that the requirement related to facilities and environment conditions of this document are met. So hence, on that example I provided previously with temperature controlled 68 degrees plus or minus 2 degrees Fahrenheit, relative humidity is less than 50%. When you go off-site, and these are for those folks that are performing, if you have a mobile facility or if you're performing calibrations or testing actually on-site at the customer's location, those environmental conditions are expected to be met. I also referenced here section 743. So often, if I can speak on behalf of calibration activities that I witnessed, with the tight conditions that are maintained in the fixed facility, oftentimes those environmental conditions are not maintained in the laboratory. So This is addressed also in section 743, the handling of tested and calibration items. Hence, let's say you were to arrive at the customer's location. Temperature was approximately 7 degrees Fahrenheit. Humidity was at 30% RH. Hence, they're well outside of the documented and specified conditions in which is specified for the calibrations to be undertaken. Hence, according to 743, what would need to be done in that instance would be the laboratory shall consult the customer for further instructions. Hence, the laboratory needs to be informed that the particular environmentals in the customer locations are outside the specifications to perform the test or calibration. And this consultation needs to be recorded. When the customer requires the item to be tested or calibrated, acknowledging a deviation from specified conditions, the laboratory shall include a disclaimer in the report indicating which results may be affected by the deviation. We went over this a couple months ago for those folks that were tuned in on that webinar on the handling of test or calibration items. So basically, if the conditions, if you're doing work at the customer's location or perhaps a mobile facility and they're out of specifications, first thing that needs to be done is it needs to be brought to the attention of the customer that results of that consultation would need to be recorded. And then lastly, it needs to be documented on the test or calibration report that would need to include a disclaimer in the report, which results may have been affected by the deviation. Okay, it's relatively short there for facilities and environment. All the requirements previously are intact. Expanded a little bit with the periodically reviewing the facility access, that sort of thing. And also expanded to include those required environmental conditions be set forth to those folks that are doing work, calibrations, testing on site at the customer's location. Okay, changing gears here. We are going to move on to section 6.4, equipment. So looking at 2017 when compared to the 2005, there's been an expansion. Standards, reference materials, reagent, and software are now considered as equipment. And we'll see conditions which are needed to calibrate equipment is set, which would include if it impacts the accuracy or uncertainty, and if the measurements need to be traceable. And reference to 17034, which is for reference material producers, has been added to emphasize that standard as criteria being set forth for competence for reference material producers. Okay, 641, nothing new here when looking at 2005 compared to 2017. The laboratory shall have access to equipment, including but not limited to measuring equipment, software, measurement standards, reference material, reference data, reagents, consumables, or auxiliary apparatus that is required for the correct performance of laboratory activities that can influence the results. So you have to have the basically the tools to do the job, including both equipment and software. Couple notes here, as we mentioned before, expansion to include reference material in this section, reagents, that sort of thing. I'll just leave this note here to have you review it in a moment for those folks that have those incorporated in their testing or calibration activities. And a note, if you're within the standard, the same applies in 2017. That's just additional information. Notes are not specific requirements. They're just additional information for the user of the standards or those that are complying with the standard to use. They're not requirements. They're additional information, added information. Note 2 talks about the Guide 233 as a guidance on the selection and use of reference material. Also references Guide 80 to provide guidance to produce in-house quality material checks. 642, when the laboratory uses equipment outside its permanent control, it shall ensure that the requirements for equipment of this document are met. So what that's referring to, if you had a need, it may apply, it may not apply to use equipment that is not within your control. Perhaps it's something that you borrow, rent. You have to ensure that the requirements of the standards that are met. Two things that come to mind is, of course, traceability. So if it's measuring equipment and it's going to be used in testing or calibration where the results need to be traceable, the requirements for traceability within 17025 would need to be met. There may be predefined limits, intermediate checks that need to be employed. Equipment may need to be checked, such as checking a balance with proper classification of test weights prior to using it in an actual test or calibration. The laboratory shall have procedures for handling, transport, storage, use, and planned maintenance of equipment in order to ensure proper functioning and to prevent contamination and deterioration. And so I'm depicting a centrifuge there. Often I come across this with laboratories referring to the manufacturer's manual, manufacturer's protocol for planned maintenance of equipment. This is crosswalked directly over from the 2005 standard. Okay, 644, the laboratory shall verify that equipment conforms to specified requirements before being placed or returned into service. A little bit of change here. 2005 was very specific. It stated that it stated calibration. Equipment needed it to be calibrated or checked to establish that it meets laboratory specification requirements. One thing that's been expanded, and we're going to get to that in a little bit, I don't want to put the cart before the horse here, is when does equipment need to be calibrated as opposed to checked or verified? Six, 4.5, the equipment used for measurement shall be capable of achieving the measurement accuracy and or measurement uncertainty required to provide a valid result. Nothing new here. What I have here I try to depict is if you had an accuracy requirement of capturing temperature to within 0.5 degrees Celsius. The instrument on the left there may not be adequate for providing that level of accuracy. Also, what I provided here, I may be going a little bit into contract, for qualification of vendors. If you're also required to have that the degree of accuracy, you go to a vendor, calibration vendor. Always, you may have as a qualifier that yes, they are accredited to do temperature calibrations. One thing you may also want to include that, are they going to be able to provide the required accuracy? So in this particular case, as you can see, a CMC is a name for, stands for calibration and measurement capabilities. In other words, that's the best uncertainty that a laboratory can produce. In this particular instance, this particular vendor is not going to be able to provide anything less than 0.66 degrees accuracy. Hence, the accuracy required, if this was a requirement for you to have temperature captured to be within half a degree C, this vendor is not going to be able to fulfill that requirement. So measurement equipment shall be calibrated when, and this is where the standard expands between 2005 2017, the measurement accuracy or measurement uncertainty affects the validity of the report's results, and or calibration of the equipment is used to establish the metrological traceability of the reported results. Hence, if your equipment needs to be traceable, that's a term that gets used, tossed around loosely sometimes. It's defined in 17025. There's an annex added, exactly what that means. So if your measurements require traceability, a calibration would be needed. If you're testing, or particularly calibration, whenever a calibration lab sends something out, uncertainty, of course, will always be needed because that's a component of your own uncertainty. Additional information as to types of equipment we may be talking about here. Those for direct measurements, for example, balance to perform mass measurement, of course, directly related to the test or calibration being undertaken. To make corrections, i.e. such as temperature measurements. Those obtain measurement results calculated from multiple quantities. One thing comes to mind is air buoyancy. Temperature, pressure, barometric pressure all needs to be captured to determine what the actual air buoyancy effect is. The laboratory shall establish a calibration program which shall be reviewed and adjusted as necessary in order to maintain confidence in the status of calibration. So if you have equipment, say it needs to be traceability needs to be incorporated with the equipment, of course it needs to be calibrated. It's not a one-time thing. You have to establish a program. Say, for instance, an annual calibration may initially be implemented. However, it needs to be reviewed and adjusted as necessary. Often questioned as far as a calibration interval. How long should that be? Well, it's something the laboratory needs to look at. Let's say, for example, you put an item out for a year, and you have 5 years of sending the instrument out. Let's say it's a stable artifact, a mass standard, a gauge blocks. And within that 5 years, you're not noticing any drift in the standard at all. That may be an indication that the calibration perhaps could be increased. Let's say, on the other hand, if you have an electronic calibration and it's drifting and it's being very, you're reviewing this on an annual basis and it's to the point where it's very close to being out of tolerance. That may be an indication that perhaps the calibration interval may need to be decreased. So this requires you have to initially establish it, and it should be reviewed and adjusted where necessary. Slight change here. All equipment requiring calibration, which has a defined period of validity, let's say you have an annual calibration set, shall be labeled, coded, or otherwise identified to allow the user of the equipment to readily identify the status of calibration or period of validity. What's changed there is the fact that in 2005, it stated it should be labeled, coded, or otherwise identified. 2017 states readily identify the status of calibration. So what that means is typically if I'm assessing to the 2005 standard, in order to fulfill this requirement, I'm typically looking for a calibration label. And that was a requirement in 2005. It had to be labeled. 2017 states it needs to be readily identified. One thing I emphasize a lot during my webinars is you can still utilize a label and comply with this requirement. Hence, it's probably the most direct means to have it readily available. If you're doing an internal audit, if you're doing an assessment to this standard, if the label's not there, it's not required anymore. However, it needs to be readily produced calibration status. So the technician should be able to readily identify the calibration status of the equipment. If it's something where they have to ask and it's maybe an hour or an hour and a half before that information arrives, then I would say that that would not constitute as being readily identifiable. So typically with a pipette that I depicted there, that calibration label, that was required in 2005. In 2017, if the pipette did not have the label on there, it does not necessarily constitute a non-conformance. And again, I'll emphasize a label can still be used, still meet the requirements. 649, nothing new here. Any equipment that has been subjected to overloading or mishandling gives questionable results or has been shown to be defective or outside specified requirements shall be taken out of service. It shall be isolated to prevent its use or clearly labeled as marked as being out of service until it has been verified to perform correctly. The laboratory shall examine the effect of the defect or deviation from specified requirements and shall institute the management of non-conforming work procedure. And it references section 710, which basically that's the requirements for non-conforming testing and calibration. So if equipment was found to be operating out of predefined limits, and it actually was used to in your testing and calibration, and the results were reported to your customers, that's stating that procedure in 710 would need to be looked at. And it's stating it's not just word of mouth. So if a piece of equipment is out of service, not operating correctly, it needs to be readily identifiable. It should be labeled, ideally isolated, to prevent usage of the equipment until it can be found to be operating correctly and producing the required readings and results that it was meant to be set, and any predefined limits were now being met, which were not being met previously. Intermediate check. When intermediate checks are necessary to maintain confidence in the performance of equipment, these checks shall be carried out according to a procedure. So often with the case of analytical balances, we may check them, have an intermediate system checks in place that incorporates test weights, where they're tested. Could be on a daily basis, could be on a weekly basis, whatever specified in the procedure. Those folks that are involved in testing, when you're using samples with blanks and spikes, that's an intermediate check on that equipment. And if that's defined in the procedures to utilize things such as spikes and blanks, those checks need to be carried out according to the procedure. Correction factors, nothing new here. When calibration or reference material data includes values or correction factors. A laboratory shall ensure that reference values and corrective factors are updated and implemented as appropriate to meet specified requirements. So those folks that may not be familiar with what correction factors are, I depict it here. An example. So when you send a say an instrument out for calibration, let's say this was a thermometer calibrated at 100 degrees C, for example. That correction factor is saying at 100 degrees C, the correction factor on that is not reading exactly 0. There's a correction factor specified as minus, if this was degrees Celsius, minus 0.2 degrees C. Gives the example there. At this particular example that's posted here, if an instrument gave a reading of 110 units obtained by adding the correction factor to the reading, the corrected results would be, when it's actually reading 110, the actual temperature is actually 109.7. So if you're utilizing those correction factors, they're often utilized in software. So when the calibration report comes back, if that correction factor is utilized in any software needs to be updated. That report needs to be reviewed. If there's a change in the correction factor, it needs to be updated. If you're using them in handwritten data sheets, that form may need to be updated to reflect the change in the correction factor. The laboratory shall take practical measures to prevent unintended adjustments of equipment from invalidating results. So if you have a equipment and it's a traceable equipment, the integrity of that traceability needs to be met. So what I try to depict here, these are more mechanical type of adjustments. On the left there is a lead wire seal. If that seal is broken, that's sealing in the adjustment mechanism for this particular piece of equipment. The integrity of the traceable calibration would be questioned. To the right there is that depicts a pipette calibration. Hence, there's often an adjustment that can be turned to increase or decrease the volume. Typically, that should be covered up with a seal. If that seal is broken, then the integrity of the traceable results may very well be in question. So oftentimes, the calibration provider ought to seal these for you. So one thing you may want to make sure when the equipment is brought back, if you know where those adjustment mechanisms are, that they are sealed. With electronics, often it's more coded. You have to know a calibration code, get into the electronics, and it could be also protected by that unique identifier that may only be known by the manufacturer or the folks that actually did the calibration. Okay, records brought forth directly from 2005 are the requirements for records. So the records shall include, and I highlighted there where applicable. There may be cases where they may not be applicable to your particular organization or for a particular test or calibration. These are still intact. One thing I want to state here is these records, they don't all have to be in the same place. They just have to be maintained within the laboratory. So what's included in that is the identification of equipment. It also includes software and the firmware version, the manufacturer's name, type, identification, and serial number, or any other unique identification, maybe an asset number or a unique ID number that you assign for your organization. Evidence of verification that the equipment conforms with specified requirements, or if you are specifying, or have those intermediate checks in place. If if you think about it, then it's also specified here in a little bit. The calibration would also provide evidence of this. The current location may be applicable, may not be applicable. If you're a calibration company, you have technicians that are assigned specific equipment, and they're going out doing these calibrations on site at the customer location. I would say in that case it would be applicable. Who's assigned what equipment? E is calibration. Calibration dates, results, adjustments, acceptance criteria, and the due date of the next calibration or the calibration interval. Has to have a record. Reference material documentation of reference material, results, acceptance criteria, relevant dates, and the period of validity. Reference material may in fact have a specified shelf life associated with it. The maintenance plan and maintenance carried out to date where relevant to the performance of the equipment. Details of any damage, malfunctions, modifications to or repairs of the equipment that was to happen. A record needs to be maintained within the lab, showing what exactly, detailing exactly what was done and what happened. Okay, that would bring an end to the presentation. I apologize. I just noticed a mistake there on the screen. That was probably carried forth from another presentation. Of course, this is section 6.3 and 6.4. This time is allocated for questions. So let me go. I'm just pulling this up now. Give me a second. Let me see what I have here. I have several questions. Who and where and how to download the current and past webinars training slides. I actually went over this at the beginning of the webinar. On our website, pjlabs.com. At the top is a tab that says webinar. Hit that tab, go to recorded webinars. You can find this one. And as I stated before, we have a couple years of past webinars. Who is the primary contact person we can talk, email, or have other questions related to past and current training? That would be actually, again, I can refer you to the website. I'm directly involved in that. Tracy Sorensen, she's President Operations Program Manager at PJLA. We often post these on our website. I don't know if we have anything. I know we have some things in the works for 2019. We offer, and we've done some of these this past year. I personally did a couple up in our Troy, Michigan facility on internal auditing, which goes through the entire ISO 170-2017 standard. We also do a one-day transition workshop, which is basically those folks that are already versed in the 2005 standard. It looks at the key differences between the two. Both are very good. They both offer practical, they both offer interactive exercises, group activities, case studies, those sorts of things. As far as who to contact, as far as anything concrete and official, if it's out there, it's on our website. If you're already accredited with PJLA, you should be getting mailings. So if you're not on our contact list, contact your scheduler if you know who that is, and they can add you to the mailing. So if we when we get some things definitely concrete etched in stone, they'll automatically be sent to you. But I encourage you to continue checking our website. I know we're looking at doing several of these this coming year. There may be other areas that I'm not involved with, which would include, say, cannabis, that sort of thing. We have other assessors, other program managers that are involved in those. So as far as an individual person, right now that would be Tracy Sorensen, but when they become official, they will be posted on our website. I'm reading through the next question. It's kind of detailed here. Okay, I'll try to answer this to the best of my ability. It is a must to provide GPS location for location of calibration laboratory, like a certain lab above sea level. Any particular reason some auditors ask this question? Share the reason for this requirement. I don't think that's, I going through 17025, I didn't see anything specific unless that actually affects the calibration. My past experience, I did that calibrations involving newtons and force, where the I'm trying to read through this again, where the where you were in relation to sea level needed to be recorded. So if that actually impacts the test or calibration, then I would say that would need to be captured. That's incorporated in the value. So if that was say a contributor to the uncertainty, then it would need to be captured. Personally, myself, I've never asked that question, and I don't see in the standard where that would be required unless it actually impacted, had an effect on the calibrations that were being taken. Excuse me. 641. Can you talk about reference materials and software, for example, being considered equipment? Any detailed or further explanation would be helpful. Do temperature humidity gauges used for environmental? I'm sorry. I'm just getting to the next question. Reference material. They are things that perhaps you have an actual material such as lead, water. I'm not directly involved in anything other than, say, a pH solution. That would be considered a reference material. Software. Software is now considered equipment if you're getting off-the-shelf software, for example. That's also is considered a document. You may have software that's used in conjunction with equipment. That would be interfaced with equipment. That's what it's referring to. It's now considered as equipment. If it's things that are off the shelf, they also just like documents, they change. You have different version numbers. That's what it's referring to here in equipment, that you need to assure that you're operating off the latest and greatest, not just the hard document, but also the software, and particularly if it's interfaced with your equipment. I hope I answered the question directly. I think I'm not sure I'm really grasping you know exactly what was asked there. Again, I say this often. This is live TV, so I'm reading it as they're appearing on the screen here, and they're sort of running together for me right now. Do temperature humidity gauges used for environmental of the lab needs to be calibrated? Yes, if it's specified within your procedure that the example I gave, and it impacts the testing or calibration, and if it's being reported on the test or calibration, then yes, I don't see why that would not be needed or be required for to be calibrated. I got a compliment about the initial slide. I had a picture there. Somebody, I think, eating pizza next to a test that was being performed, and it had a cat, which I was trying to show add things that may adversely affect the test or calibration. I'm assuming that's what you're. Oh, so it must be an ice lab. So yeah, I did find one on my initial lab that looked very clean and had a lot of equipment in there and a lot of space between the equipment. This appears to be an area of testing, major test equipment, HPLC, ICP, LC, mass specs, those sort of things, is not usually calibrated, but instead shown to be performing up to specification in, I guess, preventive maintenance visits. Does this qualify? Does this satisfy? Well, we went over specific. You had to verify or you had to calibrate. If it is specified that there's measurement components in there and it needed to be a traceable measurement, then it falls within the realm of calibration. If it is a component and it affects the accuracy, or the uncertainty, then it specifies a calibration there. But it also may, and I'm not testing. I'm not involved in the assessment of organizations that are using this type of equipment. Is a verification acceptable? If it does not fall within those two buckets, then the standard allows just for equipment to be verified before being put into service. Is it possible to request a training slide? Anybody who I can provide you directly a copy of these slides. Of course, you can go to our website and listen to the recorded version. If you would like a copy of the slides, if you could put in the subject bar webinar, and you could send that request directly to me, I'll be more than happy to send them to you. My email address is M as in Mike, Kramer with a K, Kramer, at pjlabs with an S at the end, .com. So if anybody would like a copy of these presentations, send that request directly to me. I'll be more than happy to send it to you. Again, the recorded version is up on our website. And great presentation. Thank you for the compliment. I appreciate that. Okay, good questions there. I hope I answered everybody's question. To your satisfaction. Some seemed a little vague to me because it was outside of my realm of technical expertise. I'm a calibration person, and I'm not involved in all types of calibrations. That particular question about the GPS and requirements of the where you are in relation to sea level was sort of a head scratcher to me, because I've never come before in a calibration that needed that, unless of course air buoyancy, for example, buoyant effect, that temperature, pressure, relative humidity, that may vary in relation to sea level. Okay, well, believe it or not, we wrapped up our webinars for 2018. We've already got, and it's already posted on our website, the first quarter for 2019. So mark on your calendar, our next webinar is scheduled for January 24th, 1 o'clock Eastern time, which is the time zone I'm coming from you here in Virginia. That's my home base. And we're going to look at section 6.6, externally provided products and services. This particular section combines purchasing and subcontracting from the 2005. Before I log off of here, on behalf of everybody at PJLA, I want to wish everyone happy holidays, Merry Christmas, Happy New Year. I appreciate everybody logging in. I appreciate all the good questions. And I hope you find this webinar and useful. And moving into 2019, I hope to put together some very informative webinars, and look forward to seeing everyone in 2019. So again, happy holidays, everyone, and look forward to having everybody log back in with us January 24th, believe it or not, 2019.